In this video, I'll compare some well-known instant messaging platforms. I'll focus on the platforms that are open source and the other requirements that they must have end-to-end encryption for both group and two-party conversations. The apps I selected are Signal, Briar, XMPP, Matrix.org, Threema, and Session. And just so you understand the dangers, I'll compare these to WhatsApp. Some of these have acceptable use cases even though there may be some imperfections related to privacy. Then at the end, I'll pick which ones stand out from the others in 2021 and why. The comparison, of course, will be based on whether they do a good job for privacy, not just message encryption, which are actually two different things. So stay tuned. I'm on the video platform Odyssey.com. You can follow me there using the link in the description. You all need a VPN to protect your privacy. I run my own VPN service for those that want to be on the down low, and it's Bytes VPN. It comes with Tor, Pi-hole for ad blocking, and servers worldwide. Your purchase of a VPN subscription supports this channel, and it's so appreciated. When looking at secure and private instant messaging solutions, there are certain issues that are important to consider. Let me explain what some of these are. Each product may have a particular design objective. Some are anti-censorship, some are to protect against government tracking or use for group communications in a protest. Some are focused on privacy. Obviously, I'm focused on the privacy part, but because of different use cases, some are really good for specialized uses, and I'll make sure to bring that up. As mentioned in my other videos, metadata can be very revealing. Message content can be inferred just by knowing details like who you're talking to, how frequently, and the length of the message. Some platforms collect contact info and spread it in contact lists. Some products require a phone number or an email address. In general, the collection of identity information is a big negative. Centralized reading and collection of contact lists and phone numbers is a big no-no to me because this is one of the worst things that you can do for privacy. It basically connects people with a relationship map, which is used with extreme frequency by three-letter agencies, and they use it to analyze connections between people. And I'm sure by platforms like Facebook. Proprietary systems will often lie about support for end-to-end encryption. Just because they state that there's end-to-end encryption doesn't mean it's the case. Plus, the metadata collection can be done without being stated at all. In general, for privacy reasons, I'd stick to open source. In some cases, some apps like WhatsApp will state the open source protocol they use for encryption. It's not perfect since you don't know how they implemented it, but at least it's better than nothing. Then there are apps like iMessage and Skype that are claimed to have end-to-end encryption, but you would be foolish to believe this since there's no way to verify this claim. Skype, for example, is subject to a US law called CALEA, which would allow for tapping of a conversation if requested by law enforcement. So ignore the hype. Go for something verifiable. There are actually two kinds of end-to-end encryption. One is the regular two-party encryption that has existed for a while with apps like Signal and Telegram. And lately, many more apps are promising end-to-end encryption for group messages. For this video, I'm only considering apps that offer both. It is important for usability to know how to have people contact each other on the app. In some cases, platforms require an exchange of keys like GPG, which is very tedious to manage. Some require out-of-band sharing of a friend connection. Some are very simple and are like email, where you just have an identifier that's easy to transmit. Some promising platforms only work on mobile phones. Some only work on Android, and some work on both mobile and PC. I would prefer those that work with the most number of platforms. Can you run your instant messenger on different platforms simultaneously? Some are tied to a device, so you need to migrate from one to the other. You can't be active on multiple devices. And some allow multiple devices. Is there a central server managing the messaging? This can be one point of failure. A government could shut down a central server. A three-letter agency could monitor traffic to a single entity. And some are based on many independent servers similar to the way email works. This is called federation. Email is federated, like gmail.com, outlook.com, those are different servers. Peer-to-peer means that the actual messages are exchanged from device to device directly, and there's no central storage. Some work in combination. The metadata and notifications are centralized, but the actual message passing occurs peer-to-peer. Is the internet required? An interesting concept here, but some of these messaging apps will function without an internet connection or with occasional internet. This is helpful for certain use cases. This introduces some limitations too, but some specialized users could find this of value. Now that we understand the issues that need to concern us, let's apply this analysis to specific apps and platforms, and we'll see which of these matter in 2021. Signal. Signal is an old-timer. It is open sourced. The Signal protocol for end-to-end encryption has withstood the test of time, and it is in fact used in some variation by many of the other messaging platforms using end-to-end encryption. There was a recent claim that the security company Cellebrite broke Signal. Cellebrite is basically into collecting information for law enforcement. I believe this is an Israeli company. Kind of scary what the focus of this company is. So it was concerning when they made the claim about breaking Signal. But apparently it was a false alarm. The message transport is still secure. What happened was that they apparently are able to read the messages stored on the phone locally, and this requires physical access. But this is likely true of all apps. Assuming you first break the security of Android or iOS, then we can assume that you can log in and see what's in the apps. Signal is very practical because it also includes support for voice over IP, VoIP, or voice calling and video chatting between two people. This is not often available on other apps, but Signal has disadvantages. It requires a phone number and it collects contact lists, which they then use to alert other people that have your phone number. This centralized collection of data, even if someone claims that they are hashed, is easy to use to create relationship maps, which draws connections between people and exposes it potentially to third parties. Phone numbers, of course, are tied to real identities, since KYC, know your customer laws, often mean you give your ID, name, and address to get a phone number. Signal is working on removing the phone number requirement, so this may change in the future, but at least in 2020, up to 2021, it's gonna be like this. Signal only works on iOS and Android, so there's no way to communicate using a computer. It also works with a single device at a time. Briar. Briar is a newer app that you will often hear mentioned within cybersecurity circles. It's pretty unique among the messaging systems because it's made to run peer-to-peer. It is open source. It has no central server. However, the question I have, and this requires more digging, is that peer-to-peer means that it has to announce a current IP address and port somewhere. And that's how peer-to-peer works. But then once that is known, devices can connect directly. It is not explained how it manages the peer-to-peer sites without some intermediary, but there has to be an intermediary. What is clear is that the actual messages are transported only from phone to phone. And by the way, this only works on Android phones. So that's a particular limitation. It also works with one device at a time. It's also not simple to add contacts. If you're physically close, you can exchange identifiers using a QR code, and you can find yourselves in a Wi-Fi or Bluetooth network. On the internet, you'll need to use some out-of-band method of passing identifiers so the devices will sync. So it's a little inconvenient to use for normal average day-to-day messaging. It's a more powerful concept for use by people with some serious government avoidance issues like activists, whistleblowers, and journalists. When Briar uses the internet, it uses Tor, so when it passes peer-to-peer connection info, it is likely obfuscated from view. Now, because it is peer-to-peer, it requires that devices having a conversation must always be awake. This is not possible on an iPhone, and that is why they don't support an iPhone. Also, because there's no forward and store option, it can cause messages to be delayed and thus affect the ability of this platform to function as instant messaging. It's not suitable for large groups of general contacts. It certainly cannot be a substitute for texting, which an app like Signal can handle well. But it is unique in its handling of peer-to-peer communications, and the only one that can work without an internet. It can use any Wi-Fi and a LAN and Bluetooth. Matrix. Matrix has grown to be very popular. It's actually made up of two distinct parts, and we have to be very clear on what is being discussed. The protocol itself is managed by matrix.org. And in theory, anyone can build any client application to work with a Matrix server. The most popular client used in Matrix is the app called Element, or previously known as Riot.im. This is what most people use when they claim to be on Matrix. Element is a for-profit company, so it actually sells subscriptions to a Matrix server. Matrix is more than just a messaging platform. It's actually a protocol for exchanging different kinds of data from different sources, and because of this, it is more complex. Matrix has the capability to integrate with other messaging platforms like WhatsApp, Telegram, and Signal using software called bridges. So this gateway concept is an interesting approach. As a messaging platform, Matrix is open source and does not require a phone number, and it features end-to-end encryption and is presumably built using the concept of federated servers. So many servers can be running Matrix. However, this is only theoretical. Because Matrix is such a resource hog and most people on Matrix use Element, it turns out that the bulk of the users will be in a few servers. Likely 1/3 of all users are on matrix.org itself, and the bulk of the rest on element.io servers. So though this is touted to be federated, in practice that's not the case. It's mostly centralized, and it gets more centralized when you think of the metadata. For example, there's a central identity server called vector.im, which not only verifies people's identities, but also stores metadata like email and phone number. And this central identity server is contacted by all servers. I'm sure this kind of ease of finding parties is what propelled Element and Matrix to popularity, but I think it's kind of a sellout approach since for privacy reasons, I wouldn't call Matrix private at all. Relationship maps, identifiers of all sorts, even IP addresses could be collected with interactions with Matrix modules. So frankly, even with end-to-end encryption, Matrix strength is not about privacy. I would not consider this a real instant messaging secure solution. Its main objective actually is laudable. By providing a way to have data flow outside of any big company like Google or Facebook, its main purpose is to prevent data collection by the large companies. I would look at it more like group social media with some strong security features. Because it's meant more to access social groups, end-to-end encryption is not automatic. You have to specify it. As I mentioned earlier, most people who use Matrix use the app Element, which is available both on phones and a PC. XMPP. XMPP, previously known as Jabber, is a very established instant messaging protocol. At its most basic level, it is based on transporting data in XML format. The XMPP protocol is very popular but hidden. It is actually the messaging protocol built into WhatsApp, Zoom, and Google messaging, and it's also used by large entities like the NSA, the US military, the German police, to name a few. The biggest user of XMPP is WhatsApp, but it basically took the open source and revised it, and WhatsApp operates closed source now, so whatever changes they've made to XMPP is not shared with the XMPP community. XMPP is an example of a truly federated platform. There are hundreds of public servers supporting XMPP, and maybe thousands of private ones. Although some are private, like I mentioned, the bulk interoperate with each other. In a lot of ways, communicating via XMPP is like email. I run my own XMPP server, which is xmpp.brax.live. I have an XMPP address, which is robbraxman@xmpp.brax.live. It looks like email and is easy to share. So in theory, anyone can send me a message as long as you know my XMPP address. This makes it very usable. You can choose to join any XMPP server. But the neat thing about XMPP is that if you run your own server, you are completely private since no one else can see your server. No different than running your own email server. Except that XMPP features end-to-end encryption using a newly added feature in the last few years called OMIMO, and this is the end-to-end encryption plugin. So no one else can read the content even on the server, not like email. But corralling yourself to your own XMPP server limits the spread of metadata. XMPP also requires no identity since just like email, you can invent any name. In my case, I use an open source server software called Prosody, which is fairly easy to install. XMPP is very efficient. One small server can support thousands and thousands of users, maybe even a city. The XMPP is actually just a protocol, so you have to use different apps depending on the platform. On Android, the best app you can find is called Conversations. On iOS, there's Siskin.im and Monal. On desktop PCs, the one to use is Gajim, and it works on Windows, Mac, and Linux. So basically, XMPP works on everything. Now, not every server supports all the XMPP features like voice over IP, file storage, video, and so on. Some of that requires the app Jitsi. But the messaging part is universal. It also works with multiple devices simultaneously. The main advantage to XMPP in my mind is that there's no required identity, and that makes it private as heck, and very secure with the OMIMO encryption. The biggest negative of XMPP is that it is not as flashy as other platforms, primarily because apps are not as popular, so there's not as much of an investment in the UI as the other platforms. And I'm not counting apps like WhatsApp that uses XMPP. Threema is used heavily in places like Germany. It has end-to-end encryption and was recently open sourced. It has centralized servers in Switzerland and also has centralized authentication. The good news is that it doesn't require an email or phone number. In theory, they claim the message storage is just a forwarding function. Actual messages are removed after they're forwarded. So the actual messages are using each individual device for long-term storage. The main problem relates to privacy. Threema uses centralized authentication, and it actually uploads contact lists to the central server. Supposedly, the contact lists have hashed phone numbers and such, but this is not much protection from a security point of view. The issue is that relationship maps between individuals talking can be quickly derived from the centralized communication metadata and the identities that are further carved in stone with public keys that are centrally stored. There are no particular features stated to obfuscate other identifiable data like IP addresses and so on. So while this may be a secure solution, it would not pass privacy muster in my book. This product, by the way, was not previously open source, so this was opened up recently, and I think they claim they passed a security audit. I don't question whether they are secure or not, but security and privacy are two different things, and I'm sure this does not improve on Signal at all. It has voice message storage, but there's no support for voice over IP or video calling like Signal. And the only reason I mention this is because I'm looking for some redeeming factor that would make me choose it over Signal, which has the same glaring privacy deficiency. Session is a bit different, even just from its economic model. Session itself rides on another network for blockchain called LokiNet, which uses the Loki cryptocurrency. And those who support this network are incentivized by getting paid in Monero. The participating server nodes also have to put a large stake in before they can provide network services, and trust in each server affects the price of the stake. So there's a financial cost-reward relationship that's tied to the trusted server a node provides. I'm not sure how Session will be monetized to pay for resources. Not clear on this at the moment, but I would imagine this will come up later. By its nature, the communications between parties are controlled by replicated node servers. So negotiated conversations and the actual conversation data can flow through any of the server. This makes it bulletproof in theory against government censorship. Many servers, many ways of passing a message, and all communications using onion routing like Tor, so everything loops through at least 3 servers. I'm not clear on whether post negotiations between devices, some messages are passed peer-to-peer. It does have a post and forward capability, like email. The actual code of passing data between the servers is based on the actual code from Monero, so obfuscating identity is definitely a strong feature. Session is cross-platform, it's open source, supports end-to-end encryption fully, and is actually introducing a new protocol that is not based on Signal. All traffic inside Session is passed through the low-key net, which, as I said, operates using onion routing like Tor. So that's how the actual identity data is disconnected from the actual user. But since the users aren't as many as Tor, they fully admit it's not as unbreakable as Tor is at the moment. Of all the products out there, this is the only one that clearly focused on the elimination of metadata. Their white papers demonstrate a very sophisticated understanding of privacy threats, not just security threats. However, it is very new and not yet mature. I think this is something to watch out for in the future because the thought process for privacy is the most sound. WhatsApp. Now, let me talk about WhatsApp just to contrast it with the other platforms I just mentioned. WhatsApp is ultra popular, of course, particularly in certain countries. The actual communication protocol is running XMPP, and a lot of the encryption is based on the Signal open source. The dangerous aspect of WhatsApp is the intentional data collection. Zuckerberg lures you into supposed secure messaging in that your messages cannot be read. This is the claim. We cannot really be certain because, of course, WhatsApp is not open source, but it is clear that the metadata is collected and matched to Facebook and Instagram accounts. Remember that Facebook is unique because it is one of the few platforms that mandate having a real identity, which is crowdsourced to be accurate. This sharing with Facebook is very clear because it is stated in the terms of service. That makes this app a very dangerous thing for truly secret conversations. If you're talking to your Facebook friends on WhatsApp, the damage is already done by being on Facebook. And I've given the scenario many times. Someone is having an affair and decide to use WhatsApp. But now Facebook knows who's talking to whom. The fact that the users are not connected on Facebook, the time of conversations, the patterns of conversation like length. It is pretty easy for a Facebook AI to identify who's having secret relationships since Facebook knows everyone's real identity. So frankly, this is a very stupid app to use. This app has nothing to do with privacy. It's a way for Zuckerberg to lure you into his kingdom so he can spy on you more. It's not open source. I don't trust any group discussions to be encrypted, and it is tied to the most dangerous platform for privacy on earth. Dump it. Standouts. Among this group of instant messaging apps, I'm going to recommend 3, but each has a different use case. I can imagine that some might find occasion to stick to 3 depending on the situation. I think these 3 stand out in particular ways. Number 1 standout, XMPP, for communicating with people you don't know. XMPP stands out as the best way for communicating with people you don't know. It's basically like email, except that it offers full encryption, so you never have to worry about your messages being read. XMPP requires no identity, so the metadata is minimal to non-existent. If you run your own server, it is non-existent. Since it can operate with many hundreds of servers, it is not likely that the metadata can be centrally collected. This is the best example of a federated network of servers. I've opened up my own XMPP server, which is xmpp.brax.live, which I offer for free. You can use it if you want. I do not offer file storage or advanced services though. It's primarily for text message. Other companies like Conversation.im offers paid servers that provide more extensive support for advanced features. XMPP is great for a business because it can build a completely private communication system using publicly available modules that work on any platform. You can restrict membership on a server if you wish. Yet it can be reached by other XMPP servers simply by giving your XMPP address, which is like an email address. The big negative with XMPP is that not all XMPP clients are equal. Some clients like Conversation.im on Android works flawlessly with Omimo encryption and other features. The Gajim client on desktop computers works with all platforms, but it is not an attractive app. It is very simplistic with limited formatting, and there are occasional glitches. On iOS, the options are Monal and Siskin IM. There are others, but these seem to have good reviews. It is very easy for anyone to reach anyone else since an XMPP address is like an email address. My XMPP address, like I said, is robbraxman@xmpp.brax.live. But I get hundreds of messages, so it is not possible for me to respond to you all. Number 2, Signal for communicating with people you know. As I mentioned earlier, the biggest negative to Signal is the metadata dispersed with the phone number and contact list, which is also the exact same problem as Telegram and WhatsApp. But we can discount this problem if you use Signal with people who already know your phone number. Since no new information is being sent out, it is not a problem at all to use it with family, friends, and known business associates. What makes Signal stand out is that it is the best in class with voice over IP and video calling for two parties. It is not perfect. It is still possible that some data leaks with video streaming using something called a turn server. I discussed this in my video on video streaming options, but it is really a nice app and it works very well. It's easy to get family members to use it. You can even handle all your texting through Signal, so all messages go only to one app. Number 3, Briar for communicating with super secrecy. Briar works for small groups that have fixed contacts. This could be a good use case, like for spies. It has limited use for uncoordinated groups because it only works on Android, and it's not really instant messaging per se since both devices have to be online or some preset intermediary needs to be online. But there's a cool factor to not needing an internet connection. People in the same household or office could have an invisible conversation using Briar. I'm not sure it's convenient enough for use by executives of a company, for example, but I think the non-internet peer-to-peer use is unique, and all traffic passes through Tor, so that means you don't worry about the metadata. It's not easy to use because you have to exchange QR codes physically or pass identifiers out of band. But if you work like a journalist where you meet up and then you disperse, this could really allow truly secret communications. Definitely overkill for privacy, but a possibly fun option. I don't know how well it would work in a protest situation with a crowd unless large numbers of people are pre-connected. So maybe that's not its strength, but it's a very unique product. Obviously, there are many products that I did not mention, many because they're not open source, so I don't really have any way to verify their claims. I'm not going to tell you not to use any particular secure messaging system except for those owned by Facebook. Just be careful about using apps that rely on phone numbers. Otherwise, use what you wish as long as you understand the risks to security and privacy. There's no absolute when choosing a messaging platform. Maybe in 2022 I might have a different list of standout, secure, instant messaging platforms. Maybe Session will get into the list. In the meantime, the more you use secure instant messaging solutions in 2021 and rely less on email, social media, and texting, the safer you will be. This will be my last video for the very weird year of 2020. Fortunately, it's been a blowout year for my channel and I'm thankful that my message is being heard. Please subscribe and get notifications from me. This is really important to my channel and I really appreciate your support. See you next time.